Okay, so this should be a quick review of inverse trig that you learned back in the spring. So good news is if you can do special angles, evaluating special angles, which you should all be able to. We practiced it a lot at this point and did it plenty last year. Inverse trig is just special angles backwards. So a typical trig equation has a trig function. There are 6. There is an angle coming from the unit circle, and your job is to figure out what the value is. So trig function, angle, what's the value? An inverse trig equation has one of the 6 trig functions, but we want the inverse of it. We're given the value, and we need to come up with the angle. So it's still the same information. The sine of pi over 4 is 1 over square root of 2. It's just that we're given what angle would give you a sine value of 1 over square root of 2, and you have to come up with the angle instead of the value. So for example, here's a typical inverse trig problem. The inverse cosine is square root of 3 over 2. So let's see, we know that the cosine is the x-coordinate of the ordered pair. And we're being told that the x-coordinate of the ordered pair is square root of 3 over 2. Well, what y-coordinate goes with that? You should know that it is 1/2. Okay, so then our job is to figure out what angle gives us that ordered pair. And that ordered pair comes from an angle of pi over 6. So that's the answer to that inverse trig problem. The angle whose cosine is square root of 3 over 2 is pi over 6. So that's going to be okay if it's sine or cosine, because cosine that's the x-coordinate. You should be able to come up with the y-coordinate. Sine, that's the y-coordinate. You should be able to come up with the x-coordinate. Well, what if it's cosecant or secant? Those aren't that hard either, because you know which part of the chord of the ordered pair that those things are related to. So if I were given the inverse secant has a value of 2, so what angle would that be? Well, if the inverse secant is 2, that would tell me that the inverse cosine was 1/2. So I can convert that secant to a cosine problem to answer it. So I know that the x-coordinate is 1/2. I would then be able to figure out that the y-coordinate is square root of 3 over 2. And the angle whose cosine is, who gives me that ordered pair, is pi over 3. And that's the answer. Okay, what's the most difficult is what if it is tangent or cotangent, because tangent is the y-coordinate over the x-coordinate and cotangent is the x-coordinate over the y-coordinate. So if it's an inverse tangent or inverse cotangent, it's not as easy as just looking at the value and knowing exactly where it fits into the ordered pair. These are the common ratios for tangent. For 1/2 divided by square root of 3 over 2, you get 1 over square root of 3. So if it's an inverse tangent problem and you see that value, it comes from the 1/2 being the y-coordinate and square root of 3 over 2 comes being the x-coordinate. If you have square root of 3 over 2 divided by 1/2, you get a tangent value of square root of 3. So if it's an inverse tangent problem and you see a value of square root of 3, then that would come from the y-coordinate being square root of 3 over 2 and the x-coordinate being 1/2. And if you see a tangent value of 1 or -1, it has to come from the pi over 4 values. Okay, and then of course cotangent's the same way. It's just that it would be x divided by y instead of y divided by x. Okay, so let's look at this inverse tangent problem. So we're trying to figure out what angle has a tangent value of square root of 3. So we have to figure out which of the 7 ordered pairs, if we do y divided by x, do we get the square root of 3? There are only 7 ordered pairs, right? There's the 4 axes angles. Okay, so we have the 4 axes angles. 1, 0, 0, 1, -1, 0, 0, -1. And then we have 3 more ordered pairs, the pi over 6 ordered pair, the pi over 4 ordered pair, and the pi over 3 ordered pair. So maybe even make a list at the top of your paper. If the tangent has a value of square root of 3, you have to pick one of those 7 ordered pairs that if you take the y divided by the x, you're going to get square root of 3. And this is the winner right here. Okay, if you do square root of 3 over 2 divided by 1/2, that is how you will get a tangent value of square root of 3. So what angle uses that ordered pair? That would be pi over 3, and that's the answer. Okay, so it does get a little bit more complicated because every trig function has 2 quadrants where its value is positive and 2 quadrants where its value is negative. Okay, but we only want to have one correct answer. And we will get into this more in the next class, but there is a specific reason why we narrow it down to one quadrant to get our angles for inverse trig problems. So for example, we have mentioned this before, all students take calculus as the acronym to remember. All our trig functions are positive in the first quadrant, sine is positive in the second quadrant, tangent in the third, and cosine in the fourth. So the sine function is positive in the first and the second, but cosine is first and fourth, and tangent is first and third. Okay, so it's different combinations. So if sine is positive in the first and the second, well, how do we know if our answer should be pi over 4 from the first quadrant or 3 pi over 4 from the second quadrant to give us a sine value of 1 over square root of 2? So these are where the restricted domains come in. Okay, and so you just have to memorize those. Again, next class will go into more detail as to why they're restricted that way. But we want, for each of our trig functions, we want one positive quadrant and one negative quadrant. Okay, so for sine, we want the 2 quadrants to be next to each other. And so we can't use the first and the second quadrant because that would be 2 positive quadrants. And we want the quadrants to be next to each other, so we're not going to use the first and the third. So for sine, we're going to use the first and the fourth. That's one positive quadrant and one negative quadrant. Okay. We're also going to use those 2 quadrants for tangent because both tangent is positive in the first and negative in the fourth. And then for cosine, that won't work because if we did that for cosine, it would be 2 positive quadrants. So cosine is going to be different. It's going to be positive in the first and negative in the second. So here's how we restrict the domain for cosine. Basically, that means that if the function is sine or cosecant, tangent or cotangent, we're either going to answer with an angle from the first quadrant or the fourth quadrant. If it's cosine or secant, we're going to answer with an angle from the first or the second quadrant, depending on positive or negative. Gets a little bit more complicated because this is literally the only area you're allowed to rotate through with tangent and sine. Okay, we're not allowed over here at all. So we can't answer with our usual fourth quadrant angles. Like you can't say 11 pi over 6, you have to say negative pi over 6. So the rotation is just from the positive x-axis into the fourth quadrant because this is the only place we're allowed to be. We're not allowed over here at all. Basically though, if you were gonna say the answer from the first quadrant, you just throw a negative in front of the angle and that's how you put it in the fourth quadrant. Cosine, it's just your normal first and second quadrant, so you don't have to worry about that. Okay, so here's some examples down here. Let's say we want the angle whose sine value is negative 1/2. Okay, well, I know that sine is the y-coordinate, so the y-coordinate is negative 1/2. So the x-coordinate clearly is square root of 3 over 2. So that square root of 3 over 2 could be positive or negative. But if we come back up here, if it's sine, it can only be in one of these 2 quadrants. So it can either be positive, positive, or positive, negative. So square root of 3 over 2 would not be negative because that wouldn't go with our restricted domain. So that is the ordered pair. And so that is in the fourth quadrant. So normally we would say 11 pi over 6, but we aren't allowed to say 11 pi over 6 because 11 pi over 6 would rotate us into the second and the third quadrant. We're not allowed over there. So instead, we stay at that positive x-axis and rotate clockwise to get to negative pi over 6 instead. So we want the angle whose cosine is negative 1/2. All right, well, we know that that is the x-coordinate. And if the x-coordinate is positive or negative 1/2, we're going to use square root of 3 over 2 for the y-coordinate. And again, we know that this could be positive or negative, but because of the restricted domain, we're not going to use anything down here, so the y-coordinate is going to be positive. So we have to figure out what angle gives us this ordered pair. This is in the second quadrant, and when the first coordinate is 1/2, then it has to be a pi/3 angle, and in the second quadrant, it's 2 pi/3. And then what if the tangent value is -1? Okay, so again, tangent is like sine, first and fourth quadrant only. So if you go back and you look at your 7 ordered pairs, of these 7 ordered pairs, which one would give you 1 or -1 if you divided the y by the x? It would be this pi/4 right here, because you're dividing something by itself. So if you get a tangent value of 1 or -1, it has to come from your pi/4 angles. So it would have to be 1/√2 and -1/√2, because tangent's only in the first or the fourth quadrant, and if the value's negative, it has to be in the fourth quadrant, and that is not going to be 7 pi/4. We're going to use -pi/4. Can't use 7 pi/4 because we're not allowed into the second and the third quadrants, and we would need to rotate through there for 7 pi/4. All right, if a problem looks a little more complicated, like you have more than one trig function, you just work from the inside out. So here, the sine of the inverse cosine of 1. If it's an inverse problem, you're given a value and you have to find an angle. If it's a regular trig function, then you're given the angle and you find the value. So since there's a regular trig function out here, our answer should be an angle, okay? Because the inverse trig, they give you the value and you find the angle. Okay, so we're working from the inside out. So the inside is the cosine has a value of 1. What angle gives you a cosine value of 1? So we know that the x-coordinate is 1, which means the y-coordinate has to be 0, and that happens on the positive x-axis, so the angle is actually 0. Okay, so this means this is sine of 0, because I found out the angle whose cosine is 1 is 0. So now I have to find, that's a special angle problem right here, no more inverse. What is the sine of the angle 0? Okay, so we're talking about this ordered pair, and that's the y-coordinate, so the answer is 0. Okay, let's try one more of those. So again, inside out. So this is not an inverse problem. It's a regular trig function. So the tangent of the angle, we're looking for a value. So pi/4 is 1/√2, 1/√2. Tangent is y divided by x. Anything divided by itself is 1. So tangent pi/4 is 1. So we can rewrite this problem as the inverse sine of 1. So we need to find the angle that has a sine value of 1. It's sine, so we know that's the y-coordinate. So then we know the x-coordinate has to be 0, and the angle that gives us that ordered pair is pi/2, which is the answer. Okay, just work from the inside out. All right, going to do a few more examples with you so that you can do your practice problems. All right, number 1. So inverse cosine of 1. And note that that is the same as if I said arc cosine of 1. So anytime you use that raised to the -1 power, that's inverse, but so is this. So those are interchangeable. They both mean inverse. All right, so we need the angle that gives us a cosine value of 1. Well, cosine is the x-coordinate, so we know the x-coordinate is 1, and the only thing the y-coordinate could be here is 0, and so the angle that gives us that ordered pair is on the positive x-axis, so it's the angle 0, not to be confused with the value 0. That is the answer there. 2. Okay, what is the angle that gives us a sine value of -1/2? Again, I could also write arc sine -1/2. So if it's sine, I know that the y-coordinate is -1/2. Well, from my 7 ordered pairs, the only thing I could have for the x-coordinate is square root of 3/2. So what angle gives me that ordered pair? Remember, sine has to stay in the first and the fourth quadrant. It's positive in the first and negative in the fourth. So I need to name an angle in the fourth quadrant. Well, I would normally say 11 pi over 6, but 11 pi over 6 has to go through forbidden quadrants. So I can't say that. I just have to stay at the positive x-axis and go clockwise. So instead of 11 pi over 6, I'm going to say negative pi over 6. Number 3, inverse secant of negative square root of 2. So I need the angle that has a secant value of negative square root of 2. So the easiest thing to do there is just rewrite it as a cosine problem. The reciprocal of negative square root of 2 is negative 1 over square root of 2. So now the cosine is the x-coordinate. Only thing that the y-coordinate could be here is 1 over square root of 2. Remember, cosine is first and second quadrant. And so I need the angle that gives me that ordered pair. That angle would be from the second quadrant, so it would be 3 pi over 4. Number 4. So what about cosecant? What angle gives me a cosecant value of 2 over square root of 3? I would change that to a sine and do the reciprocal, square root of 3 over 2. Then I would know that the y-coordinate is square root of 3 over 2, which means that the x-coordinate is 1/2, and the angle that gives me that is pi over 3. All right, so let's do a few more where you have to work from the inside out. The inverse sine of the cosecant of 7 pi over 4. So you work from the inside out. Now there is a shortcut here, but you have to be careful. So when I have a regular trig function, they give me an angle and I come up with a value. If I have an inverse trig, I'm supposed to come up with the angle. So here I would be coming up with a value and applying it here, which then I would come up with an angle. So if the inverse trig is on the outside, my answer should be an angle. But that angle has to follow the restricted domain. Okay? That angle is not in the restricted domain for an inverse sine. So the shortcut is if the two trig functions are reciprocals, then your answer is just going to be the reciprocal. But I would be careful about that because this is not in the restricted domain. So be careful with that. So I would actually work it out. The cosecant of 7 pi over 4 is 1 over root 2, negative 1 over root 2. Okay, and then the cosecant of that is the reciprocal of the sine, so the value is negative square root of 2. So the cosecant of 7 pi over 4 is negative square root of 2. Then I need to find the angle whose sine is negative square root of 2. Okay, this one is actually not possible because if you go back to a sine graph, the maximum and minimum, it goes from negative 1 to 1, and square root of 2 is more, or I guess less than negative 1. So this is not possible. And I know that that's not possible because this angle is not allowable for sine. Okay, so let's do that maybe a different way. How about if I had inverse sine of the sine of 7 pi over 4? Okay, so shortcut. If the two trig functions are the same, I should just be able to cancel them out and answer with 7 pi over 4. But again, this is not an allowable angle for an inverse trig problem. So if we work it all the way through, 7 pi over 4, the ordered pair would be 1 over root 2, negative 1 over root 2. The sine would be negative 1 over root 2. So I need the angle whose sine is negative 1 over root 2. Okay, so again, shortcut, I should just be able to cross those out and answer with 7 pi over 4. But that's not an okay answer for an inverse sine problem. So instead, I have to use the angle from the fourth quadrant that doesn't go through the second and the third quadrant. So instead, my answer needs to be negative pi over 4. It would be incorrect to say 7 pi over 4. All right, let's look at another one. So if I have inverse tangent of pi over 2. So again, if the two trig functions are the same, they should just cancel each other out, like squaring a square root. But you just need to make sure the angle is in the restricted domain. So tangent and sine both have the restricted domain, so it is okay to be at either pi over 2 or negative pi over 2. But let's look at the tangent of pi over 2. The ordered pair is 0, 1, and the tangent of that is undefined. And so we need to have the angle that gives us a tangent value of undefined. So we should be able to say pi over 2. Okay, let's keep going. A couple more examples. So let's see. Tangent of the inverse cosine of 1 over root 2. So inverse trig, you got a value, you come up with an angle. Regular trig, you come up with a value given an angle. So from the inside out, there's nothing special about these. They're not the same, they're not reciprocals. Okay, so let's look at this. The x-coordinate is 1 over root 2. So I know for sure that the y-coordinate must be 1 over root 2, thinking 1/2 from your 7 ordered pairs. And the angle that gives me that ordered pair is pi over 4. So then I want to find the tangent of pi over 4. Same ordered pair, so I just have to do the y divided by the x, and the answer is 1. Okay. What if I have the inverse tangent of the tangent of 7 pi over 6? So it's a lot like the one I did where it was inverse sine and sine, but the angle did not fit the restricted domain for tangent. Okay, so normally if those are the same, I could just say, oh, they cancel each other out and it's 7 pi over 6. But 7 pi over 6 is not an angle that you would use for an inverse tangent problem. Okay, so instead, you don't really have to redo it. You just have to say, okay, well, tangent of 7 pi over 6, that's the third quadrant. That's a positive value. So for inverse, I have to give them an answer from the allowable positive quadrant. So I'd answer with just pi over 6. If you work it all the way through, you can write out the ordered pair. The tangent is negative 1/2 over negative square root of 3 over 2. So negative 1 over root 3. Oh, positive. Negative divided by negative. So the angle whose tangent is positive 1 over root 3. And so I'd only can answer with an angle from the first or second quadrant. And so then I would say, oh, it has to be positive pi over 6, not 7 pi over 6. And lastly, what if you're given values that aren't one of those 7 ordered pairs? 5/12, that certainly doesn't come from the one of the 7 ordered pairs. Anytime you're working with values that aren't from the special angles, then you're going to have to draw and label your own triangle. So tangent is positive. So since it's an inverse tangent, I'm only allowed to be using the first and the fourth quadrant. So if it's tangent and it's positive, it must be the first quadrant. Draw your triangle in the first quadrant, diagonal coming out of the origin, perpendicular to the x-axis. Then I can label 2 of the 3 sides because tangent is opposite over adjacent. So angle's always here, opposite side is 5, adjacent side is 12. Pythagorean theorem or Pythagorean triple would tell you that the hypotenuse is 13. Once you've labeled the triangle, then you're done with this because we don't actually know that angle without a calculator, right? Because it's not a special angle. So we have no idea what that angle is, so we can't find it without a calculator. So now we're just going to, once we get it all labeled, we're going to come down here and write the ratio that represents the sine. And the sine is opposite over hypotenuse, so our answer would be 5 over 13. Okay, that's it. You've got some practice problems loaded into your folder, and I want you to try those, and you're going to complete those as your work for tonight.